Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Wonderful day, Del Pilarians. You are now listening to Teleradyo Marcelo, ang telearalan ng bawat Del Pilarian. Welcome to another fun and exciting discussion, discovery, and learning about random sampling, parameter and statistic, and sampling distribution of statistics. I am Sir Miguel Angelo C. Gutierrez, your statistics and probability teacher for today. Are you ready? All right, I know you are enthusiastic to listen to our broadcast, but before that, let us set objectives of our lesson. At the end of the day, the learner should be able to illustrate random sampling, distinguish between parameter and statistic, and identify sampling distribution of statistics. So as we proceed to our discussion, let us have a short review on what we have learned from our previous topic. Okay, so what are the two parameters that characterize a normal distribution? Type your answer in the comment section of our live stream. Do not forget to indicate your strand and section. Now for the second question. This is the average of the number, a calculated central value of numbers. And lastly, a measure of the likelihood of an event to occur. Okay, so can anyone remember? Feel free to chat your answers on the comment box. So I guess everyone is done answering now. Let's check it. So for the first question, what are the two parameters that characterize a normal distribution? Is mean and standard deviation. For number two, it is the average of the number, a calculated central value of numbers. It is the mean. Then for the third, a measure of the likelihood of an event to occur is probability. Okay. Del Pilarians, if your answers are all correct, it seems that you really understood the topic last week. Okay, so before we proceed to the lesson, let's watch this video. So what have you noticed in the short clip? So the researcher is tasked to monitor the fish in the Lake Johnson. So as she monitored it, she noticed that there are two colors of fishes, red and yellow. Now she wants to know the proportion of red and yellow fish in the lake. So she randomly picks them and count them. Later on, she repeats the procedure and come up with a different result. But this time her aim is to know how many fish are there in the lake. Upon getting her second sample, she can now estimate or approximate the total number of the fish in the lake. Okay, so what does this have to do to our lesson? By using random sampling, we can study regarding the characteristic of the subject, in this case, the colors of the fish. And also, we can use this data to get the approximate number of population fish in the lake. Okay, so later on our discussion, we will tackle more about this study. So I think you are now ready for today's discussion. Listen carefully and take down notes because our topic is usually used in research subjects. Let us start by discussing the different types of random sampling techniques. Okay, so what is random sampling? Random sampling refers to the sampling technique in which each member of the population is given equal chance to be chosen as part of the sample. So now let's analyze this study. So Mrs. De La Cruz wants to get the analysis on her pretest in statistics and probability of grade 11 students in ABC High School. She handles 3 sections with a total of 150 students. Is it right to analyze the scores of a single section? So what do you think? Yes or no? Is it right to analyze the scores of a single section? Okay, so the answer is no. It is much better if she will get the scores of all the sections to produce an analysis. Why? Because the result of one section may differ from the other sections. Okay, so random sampling is a selection of elements derived from the population, which is the subject of an investigation or experiment, where each point of the sample has an equal chance of being selected using the appropriate sampling technique. Okay, so analyze the picture shown. So let's say that the target population are grade 11 students of MHPNHS. How are we going to get sample out of our target population? One method is through non-random sampling, in which we can select a specific strand, consider one gender, limit the age, or use any other characteristic as a basis of selecting our sample. Okay, so another method is through random sampling, in which we select a sample based on a statistical theory. Furthermore, so population, it refers to the whole group under study or investigation. In research, the population does not always refer to people. It may mean a group containing elements of anything you want to study, such as objects, events, organizations, countries, species, organisms, etc. While the sample is a subset taken from a population, either by random sampling or by non-random sampling. A sample is representation of the population, where it is hoped that valid conclusions will be drawn from the population. Okay, so here are the 5 types of random sampling technique. The first one is lottery sampling. Lottery sampling is a sampling technique in which each member of the population has an equal chance of being selected. Okay, so this sampling technique is very popular in every class, especially when recitation. Teachers may have an index card for each student in the class, and he or she will randomly pick one. In this case, everyone has an equal chance of being selected. Next is systematic sampling, a sampling technique in which members of the population are listed and samples are selected at intervals called sample intervals. In this technique, Every nth item in the list will be selected from a randomly select starting point. Okay, example. If we want to draw a poor sample from a population of 12, we can select every third person in the list. In practice, the numbers between 1 and 12 will be chosen randomly to act as the starting point. Okay, so from these 12 people in the population, you can select anyone there as a starting point. But how will you determine the interval? Okay, so for the interval, to determine the interval to be used in identifying the samples to who will participate in the study, use this formula. So capital K is equal to capital N over the small n. So the capital K represents the interval, the capital N is population, and the small n represents the sample. Okay, this kind of sampling is often used on long population lists. Okay. The third one is stratified random sampling. It is a sampling procedure in which members of the population are grouped based on their homogeneity. The sample is constructed by classifying the population into subpopulations or strata based on certain characteristics of the population, such as age, gender, or socioeconomic status. The selection of elements is done separately from within each stratum, usually by random or systematic sampling methods. So, in the left side of the illustration, this represents the entire population. As you can see, the population is divided into 4 groups. That is how stratified sampling works. So in this group, the first group, number 10 is chosen. And in the other group, 1 from it is chosen, so number 2. Then the third group, number 8. And the last group, number 5. Okay, another example. Using stratified random sampling, select a sample of 400 students from the population, which are grouped according to the cities they come from. The table shows the number of students per city. So for city A, there are 12,000. City B, 10,000. And city C, 4,000. And D, 2,000. So how are we going to select 400 samples out of the 4 cities? Do you think we should just select 100 students from each city? Yes or no? Type your answer in the comment section. Okay, so the answer is no. We cannot just select 100 students for each city because the population from each city is different. Each city should be well represented in our sample. Since city A has the largest population, a large portion of our sample should come from that city. Okay, for the solution, to determine the number of students to be taken as sample from each city, we divide the number of students per city by total population. Multiply the result by the total sample size. Okay, so our total population is 28,000 and the sample size we need is 400. Okay, so for city A, 12,000 over 28,000 times 400 will give you 171.42. Rounding up, we get 171. Then second, 10,000. 10,000 over 28,000 times 400 will give you 142.85. Rounding up, we get 143. For CTC, 4,000. 4,000 over 28,000 times 400 will give you 57.14. So rounding up, we get 57. Okay, so last city, 2,000. 2,000 over 28,000 times 400 will give you 28.57. So rounding up, we get 29. Okay, so you can check if you arrive at the desired sample size by adding samples of all the cities. In this example, 171 plus 143 plus 57 plus 29 is equal to 400. Another type of sampling is cluster sampling, sometimes referred to as area sampling and applied on a geographical basis. Generally, first sampling is performed at higher levels before going down to lower levels. So the left side of the picture is the entire population. We can see that it is already divided into 6 clusters. In cluster sampling, if you select a cluster, everyone in the cluster will be a respondent. Unlike stratified sampling, you will not select a sample from all the groups. Okay, so from this population, this cluster is selected. So it includes 5 and 6. That's why 5 and 6 will be included in the study. The other cluster that is picked is this one. So 11 and 12 is included in the study. Okay. Another example is the city randomly selected barangays which will be included in the sample. All residents in the said barangays will be considered respondents in the study. Okay, so the city randomly selected barangays which will be included in the sample. All the residents in the said barangays will be considered as a respondent in a study. Okay. Lastly, multi-stage sampling chooses a combination of different sampling techniques. Okay, example. When selecting respondents for a national election survey, we can use the lottery method first for regions and cities. We can then use stratified sampling to determine the number of respondents from selected areas and clusters. Okay, so now that we are done discussing the different types of random sampling techniques, let's have a short activity. Just type your answers in the comment section. Okay, for the first question, it refers to the entire group that is under study or investigation. What is this? So A, population, B, sample, C, random sampling, or D, subset. The answer is A, population. Second, it is a subset taken from a population, either by random or non-random sampling techniques. A, population, B, sample, C, random sampling, or D, lottery sampling. The answer is B, sample. So, what sampling technique in which members of the population are listed and samples are selected in intervals called sample intervals? A, systematic sampling, B, lottery sampling, C, stratified random sampling, or D, quota sampling. Okay, the answer is A, systematic sampling. It is sometimes called area sampling. It applies on a geographical basis. A, systematic sampling, B, lottery sampling, C, stratified random sampling, D, cluster sampling. Okay. The answer is cluster sampling. It refers to a part of the sampling technique where each sample point has an equal chance of being selected. A, systematic sampling, B, lottery sampling, C, random sampling, or D, quota sampling. Okay, so the answer is C, random sampling. Okay, so and those are the 5 types of random sampling techniques. Again, those are lottery sampling, systematic sampling, stratified random sampling, cluster sampling, and multi-stage sampling. Okay, comment a red heart emoji if you are enjoying our discussion. Okay, so thank you for your responses. Let's proceed to our next topic, parameter and statistic. Before we go further into the discussion, determine whether the statement is true or false. Write T if the statement is true and F if it is false. Comment your answers in the comment box. Okay, so while waiting for your answers, I would like to greet our school principal, Dr. Maria Victoria C. Vivo, our senior high school assistant principals, Ma'am Jocelyn Ramos and Ma'am Gladys Bondoc, our subject department heads, especially math department, and to all my fellow colleague teachers. I hope all of you is well. Okay, now let's answer. For number one, a statistic is a number which describes a sample. Okay, it is true. Parameter is a descriptive measure of population. Again, it is true. An example of parameter is the sample mean. It is false. The value of a parameter can be approximated. It is not necessarily equal to the statistic of a sample. It is true. Lastly, an example of statistic is a population mean. False. Okay, so Delpilarians, if your answers are all correct, it seems that the topic is easy for you to understand. So now that we're talking about parameter, what is parameter? Parameter is a measure of the characteristics of the entire population, a mass of all the units under consideration that share common characteristics based on all the elements within that population. Example, all people living in one city, all male teenagers worldwide, all elements in a shopping cart, and all students in a classroom. Okay, so next example. The researcher interviewed all the students at the school for their favorite apparel brand. So in this example, we can see that the test subject is all the student. Let's move on to statistic. It is the number that describes the sample. It can be calculated and observed directly. The statistic is a characteristic of a population or sample group. You will get the sample statistic when you collect the sample and calculate the standard deviation and the mean. You can use sample statistic to draw certain conclusions about the entire population. Okay, so example. 50% of people living in the US agree with the latest healthcare proposal. Researchers can ask hundreds of millions of people if they agree. So they take the samples or part of the population and calculate the rest. Okay, so in this example, we can see that instead of asking the opinion of all US residents regarding this matter, the researcher only selected half of the population as respondents. Okay, for the second example, researcher interviewed 70% of COVID-19 survivors. So only 70%, not all the survivors. Now that you have learned the concept about parameter and statistic, in this lesson we will study a form of probability distribution, which is known as the sampling distribution, which is our next topic. So what is sampling distribution? Sampling distribution is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. So for this topic, it is important that you know how to get the mean of a given population or sample. Please take note of this formula as it will be essential in the next examples. Okay, so the formula for the population mean, so mu is equal to the summation of x over the n. So the mu represents the population mean, and the x will be the given data in the problem, and the n is the population. Okay. So let's have an activity. Type your answers in the comment section of our live stream. You have 2 minutes to answer the following. Okay, so given the set of numbers, compute for the mean. While you were answering, I would like to thank the people behind the Teleradio Marcelo. It is a pleasure for me to be one of your teacher broadcasters. Okay, time is up. Let's answer. For number 1, following the formula, summation of x. So add all the given data in the problem, then divide it by the number of population. So 4 plus 12 plus 34 plus 45 plus 6 all over divided by 5. So the mean that we get will be 20.2. Okay, for number 2, same procedure. We get the mean of 42.67. For number 3, the mean is 88. And for number 4, the mean is 38. For number 5, the mean is 17.33. And now I will give you another example. A population consists of the 5 numbers, 2, 3, 6, 10, and 12. Consider samples of size 2 that can be drawn from this population. How many possible samples can be drawn? To answer this, use the formula of combination. The number of objects taken at a time, where n is the total population and n is the sample to be taken out of the population. In this case, the population is 5 and the sample size is 2. So 5 combination of 2 will give us 10. So there are 10 possible samples to be drawn. Okay, so 5 combination of 2 can be easily solved using a scientific calculator. But how will you be able to answer it if you don't have a calculator? Okay, simply follow the formula for combination. So we use the same data, population is 5 and the sample is 2. Then formula will be the factorial of the population divided by the factorial of the sample and the difference of population and the sample. Okay, so perform the operation. You will arrive at the same answer. Okay, so the first step is getting the number of possible samples to be drawn. Okay, next step. Construct the sampling distribution of sample means. List all the possible outcome and get the mean of every sample. Okay, so the 10 samples that we get is this. So how did we come up to this? So remember the given data, 2, 3, 6, 10, and 12. So the first combination of 2 sample will be 2 and 3. Then pair it to the next number, 2, 6, 2, 10, and 2, 12. The next number in the list is 3. Pair it to the other numbers. So 3, 6, 3, 10, 3, 12. Then next number will be 6. So 6, 10, 6, 12. Then the last pair will be 10 and 12. Okay, so get the sample mean for each of the sample. So these are all the sample mean of these samples. Okay. This time, let us make a probability distribution of the sample means. This probability distribution is called the sampling distribution of the sample means. Observe that all sample means appeared only once. Thus, their probability is 1 over 10 or 0.1. Okay, given the sample mean that we computed in the last step, we can see that all the sample means appeared only once. So their probability is 1 over 10 or 0.1 or 10%. Okay, so another example. Construct a sampling distribution of sample mean for the set of data below: 86, 88, 90, 95, and 98. Consider a sample size of 3 that can be drawn from a population. Okay, so same procedure. To answer this, use the formula of combination. In this case, the population is 5, and the sample size this time is 3. So 5 combination of 3 will give us 10 also. So there are 10 possible samples to be drawn. For manual operation. Okay, so next step, construct the sampling distribution of sample means. List all the possible outcome and get the mean of every sample. So same procedure, list all the samples given. So there will be 10 samples. Then get the sample mean for each of the sample. This time, let us make a probability distribution of the sample means. This probability distribution is called the sampling distribution of the sample means. Observe that 88, 92, and 93 appeared only once. Thus, their probability is 1 over 10 or 0.1. Since 90 and 94 appeared twice, their probability is 2 over 10 or 0.2. While 91 probability is 3 over 10 or 0.3. Okay, so observe that the total probability of all sample means must be equal to 1. So when you add this probability, the answer will be 1. All right, seems that all of you understood the topic. For your assignment, it will be posted in your Google Classroom. Just check it later and follow the given instructions. We would like to thank every student, teacher, and administrator who continuously contributes to the success of Teleradyo Marcelo, ang telearalan ng bawat Delpilarian. Once again, I am Mr. Michael Angelo C. Gutierrez, your statistics and probability teacher for today. May you continue to bring out the best in you and inspire others through your work. Bye.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo.